Hello students, in previous lecture we had completed chapter 6 and today we will start chapter 7. This is quantity and quality of sewage. This is the outline of chapter 7. This is the introduction of quantity and quality of sewage part. So, the sewage collected from the municipal area consists of wastewater generated from the different sources like different residences, commercial centers, recreational activities, institutions and industrial wastewaters discharged into sewer network from the permissible industries located within the city limits. Before designing the sewer line, it is necessary to know the discharge. That means the quantity of sewage which will flow in it after completion of the project. So, before designing any sewer network or the pipeline or the sewer line, it is necessary for an engineer to know the details of the quantity of the sewage, also to know the quality of sewage. Sources of sanitary sewage. The first and the most important and the primary sources of sanitary sewage is the domestic sewage. Water supplied by water authority for domestic uses, after desired use it is discharged into sewers as sewage. The number 2, industrial sewage. Water supplied to the various industries for various industrial processes by local authority. Some quantity of this water after use in different industrial applications is again discharged as wastewater. Number 3. The water supplied to the various public places such as schools, cinema theatres, hotels, hospitals and commercial complexes. Part of this water after desired use also joins the sewers as wastewater. So, these are the primary sources of sanitary wastage or sanitary sewage of a city or a town. In order to find out a suitable section for the sewer, it is necessary to determine the quantity of sewage that will flow through the sewer. The sewage consists of the following two categories. Number 1, dry weather flow. Number 2, stormwater or wet weather flow. So, these things or the categories will depend or we categorize them according to the different weather condition. Number 1, dry weather flow, DWF. The flow that occurs during dry seasons is combined system. This flow indicates the flow of sanitary sewage. Again, it consists of two parts. Number 1, domestic or sanitary sewage. Number 2, industrial waste. So, the sewage or waste we get in dry season or in dry weather, basically we call them as dry weather flow. Then some factors which affect the dry weather flow. First factor, rate of water supply. The dry weather flow varies from day to day and also from season to season. So, generally, the rate of flow of sewage is nearly equal to the rate of water supply. But practically it is not possible as there is chances of evaporation of water. So, the dry weather flow is 60% to 70% of the rate of water supply. Number 2, population. So, obviously, if population is more in a particular area or in a city, then obviously we get more sewage or more wastage. Number 3, nature of area. So, sewage also depend on the nature of area. For example, residential area or industrial area or rural area. The amount of sewage generated depends on the nature of the area. Number 4, infiltration. The sewage flowing in the sewer line depends on the infiltration rate of that particular area. If the infiltration is less, then the storm water produced will be more, which will increase the flow through the sewer line. Number 2. Stormwater or wet weather flow or WWF. The amount of sewage that flows through the sewer line during rainy season is known as wet weather flow. So obviously the sewage or wastage which we will get in the rainy season or in wet weather, we call them as stormwater flow or wet weather flow. It depends on various factors such as intensity of rainfall, characteristics of catchment area, duration of storm, etc. These are the main factors on which the wet weather flow depends. Next, self-cleaning velocity. It is the minimum velocity which the sewage must flow within the sewer pipeline to avoid any deposition in the sewer line. So it is the minimum velocity with which the sewage can pass. The sewage can easily pass or easily flow through the sewer line or pipeline without any blockage or without any deposition. The self-cleaning velocity varies from 70 cm per second to 100 cm per second. The self-cleaning velocity depends on the amount of waste solid particles and their size. So the velocity or the self-cleaning velocity also depend on the amount of waste solid or amount of wastage or sewage, also their particle sizes. Scoring velocity. Scoring velocity is the velocity beyond the permissible velocity of flow at which the cross section of the sewer line may be damaged. That means what? Now the scoring velocity is the velocity beyond than the permissible velocity or a limiting velocity, after which there is chances of damage or broken of sewer line or pipeline. Non-scoring velocity. Non-scoring velocity is the maximum permissible velocity with which water can flow without damaging the inner surfaces of the pipeline or sewer line. So it is the opposite of the scoring velocity. It is the maximum permissible or limiting velocity at which the sewage can easily pass or flow through the sewer line or pipeline without damaging or without hampering the flow or damaging the sewer line. This is the non-scoring velocity. Next, Chezy's empirical formula. So, V equal to C into square root of Mi. This is the Chezy's empirical formula. Here, or by applying Chezy's empirical formula, we can calculate the velocity of flow. This is the velocity V equal to C into square root of Mi, where V equal to velocity of flow, M equal to hydraulic mean depth, I equal to gradient, C equal to Chezy's constant. Then Mannings empirical formula. Also, we can find out the velocity of flow by using Mannings empirical formula. The formula is V equal to 1 by n into m to the power 2 by 3 into I to the power half, where n equal to Manning's rugosity or roughness, Q equal to A into V. Q means discharge. Capital Q stands for discharge. A equal to cross-sectional area of sewer or pipe. V equal to velocity. Again, M equal to, the formula is area by weighted perimeter. This is the hydraulic mean depth. M equal to hydraulic mean depth, whose formula is area by weighted perimeter. So this is the problem. Determine the diameter of sewer when running full, considering self-cleansing velocity of sewer line is 1.6 meter per second, slope 1 in 800 and Chezy's constant 70. So this is a given data. Self-cleansing velocity is given, v equal to 1.6 meter per second. Slope or gradient I equal to 1 in 800 or 1 by 800. C equal to Sewage constant, this is 70. Again here we have to find out the diameter of sewer, that is the notation we give it as small d equal to question mark. So in the question it is mentioned that we have to apply the Sewage constant, or as it is given here the Sewage constant, so obviously we have to apply Sewage empirical formula to find out the diameter of the sewer line. So we know that v equal to c into square root of mi, where m equal to, we know the formula, area by weighted perimeter, or implies m equal to area, that means the area of the pipe or sewer. It is in circular, so the formula is pi r square divided by weighted by perimeter, this is 2 pi r, or implies m equal to r by 2. After cancellation the value is r by 2. So v equal to c into square root of mi, already we know. Here the v value is given in the question, so we put it here 1.6 equal to c value is 70, already given in the question. Square root of the m value, we put it here r by 2, as we have to find out this one, this is the unknown, r is the unknown, into I value also given in the question, this is 1 by 800. Then we calculate it. After calculation we find it r equal to 0.83 meter. This is the radius, but in question it is asked to find out the diameter of the pipe. So again diameter d equal to 2 into r, where d equal to 2 into 0.8, this is the value 83 or 8, and d equal to finally 1.67 meter. This is our answer. So in next class also we continue this chapter 7. Also we will solve more problem in next class. Thank you.